In question 16 of chapter 10 of our physics textbook, it talks about how a school has a wind turbine with 3 blades, and each of the blades are of the same length at 4.6 meters, and each individual blade weighs 45 kilograms. And the question basically asks if the turbine is spinning at 240 revolutions per minute. It's asking what is the kinetic energy of the blade apparatus. So basically, to solve for this question, what we have to do is we're trying to get to this equation here, which is kinetic energy equals 1/2 times the rotational inertia times by the angular velocity squared. But to get to that, we don't have our rotational inertia, so to get that we have to use this equation here, which is the inertia equals 1/3 times by the mass times by velocity squared. And so using the information we were given in the problem, we should be able to solve for our rotational inertia of the blade. But because there are 3 blades, what we can do is times this basically by 3 to get the rotational inertia of the blade assembly. So if we times all this by 3, it should give us our inertia that we need to plug into this final equation. And since we're timesing it by 3, we basically cancel out this 1/3 here, which means that we're just basically left with our this should have been the length. The mass times the length squared. So what we do is we put in our values that we have up here, and so our inertia equals the mass, which was 45 kilograms, times by the length of the blade, which was 4.6 meters squared. So once we run this through our calculator, we should get that our inertia equals 952.2 kilograms times meters squared, which is the inertia that we need to put into this final equation. But to do this final equation as well, we need to get our angular velocity in seconds in order to get the units that we need. And we're provided with revolutions per minute, and so we need to convert it to radians per second. So to do that, we take our revolutions, which was 240 revolutions per minute, and then for every 1 revolution we get 2 pi radians, and for every minute we have 60 seconds. So we'll put our minutes up here so it can cancel out, and then when we cancel out the units, we're left with radians per second. And so when we run this through our calculator, we should get 25.13 radians per second. And so now that we have it in seconds, we can input it into this final equation and solve for our kinetic energy. So when we input all the information we have, we get K equals 1/2 times the rotational inertia, which is 952.2 kilograms times meters squared, times by our angular velocity of the blade apparatus, so 25.13 radians per second, and then we have to square that. And once we run this through our calculator, we should get that our kinetic energy of the blade assembly equals 3.01 times 10 to the 5th joules, because once we cancel out the units, we're left with kilograms times meters squared divided by second squared, which is joules. So this would be our final answer for question 16 in chapter 10 of our physics textbook.